Okay. Hello students, welcome everyone. Welcome to this session on signals and systems. So we will be solving some very interesting problems here and signals and systems is very important topic for EC Triple IN branch. So let's get started quickly. So we will quickly look at the instructions for playing this quiz. So you will be given with 5 very interesting questions. Each question is going to be timed. So you will get approximately 2 minutes for a question. The link to join the quiz is given here. bit.ly/tga079e. So this is the link to join the live quiz. Please, I request all of you to join this quiz and take participation in this. So how to play the quiz? So the quiz is going to, all of them are going to be either multiple choice questions or it's going to be numeric type of questions. So you'll be given 2 minutes per question. There are no negative points. The number of points per question will be displayed along with the question, and it's going to be tougher questions are going to have more points, and faster, that's going to make the quiz interesting. Faster you're going to give the answer, more is going to be your score. Okay, so let's get started. So we are waiting for the students to join. We'll wait for a couple of minutes for the students to join. So Vikas has joined. Good. Welcome, Vikas. Let's wait for 1 more minute. Okay. Okay, let's get started. So here comes the first question. So this is going to be a very interesting multiple choice question. Let's see. X of t is given to be a signal. X of t is sampled at 5 kilohertz. The sampled signal is reconstructed as an analog signal y of t. What is the obtained y of t? This is a very interesting question. Let's see. Yes, we have around 90 seconds remaining. Wow. Wow, all of us have answered already. So, yes, we have only one person giving the correct answer. Let's look at the scoreboard. Wow, Vikas is leading the score. Let's see. Good. Here comes the second question. Y of z is given to be z by z minus half into z minus 2. This is the z transform of y of n. The region of convergence is given, and they are asking you what is y of n. How to proceed here. This is another very, so all these questions appear to be straight, but they are not straightforward. Wow, I think many people have given the answer. Oops, no one has given the correct answer. I think many of them have taken the bait. Let's see, let's see. These questions are very, very tricky in nature. Let's see. We'll go to the third question. X of n is given to be 0.9 power n sine pi n by 2. What is the energy of x of n? This is a numeric type of question. Let's see. Come on, we need some tough competition here. Come on. See, these type of questions are very, very important in GATE. All these are like very good problems from previous year competitive examinations or GATE or similar GATE-like examinations. So, and these questions have real lot of applications in the real life also. So, when we finish our engineering and we start designing systems for processing signals, all these concepts of signals and systems need to be kept in mind. So, good. So, close to last 30 seconds remaining. Let's see. Nobody has given right answer. Everybody has given wrong answer. Again, as I told you, these are very tricky questions. We need to be very careful here. So Vikas is leading. Good. We need others to catch up. Let's see. This here comes the fourth question. We'll look at the solution for all the problems towards the end of the session. So x of z is log of 1 minus 2z. And the region of convergence is given to be z greater than half. What is the value of small x of 2? Small x of 2. Small x of n will be the inverse z transform of capital X of z. Let's see. We have close to last 30 seconds remaining. And see, these type of questions are like very interesting off the beat questions from Z transform because these are like standard functions. Then we will know to take the Z transform, inverse Z transform directly. But here it's something other than that is given. Let's see. Okay, here also nobody has given correct answer. Let's see. Here comes the last question. The Fourier transform of unit step signal is It doesn't exist. 1 by j omega, 2 pi by j omega, pi delta of omega plus 1 by j omega, like the different options are given. See, the options are also not randomly given. There is a reason because why these options are given. These options, all these options make sense in one way or other, but still there's only one correct option. The other options are very, very close, but it's going to be sort of cunningly given to confuse the students. So we have close to a minute remaining. Let's see. Okay, good. We have one person giving the right answer. So let's look at the final leaderboard. Wow. Renuka tried to catch up. Good. Vikas is the leader, winner with congrats, Vikas. Congrats. So I'm going to stop this sharing. We will discuss the solutions quickly. So I feel free, students, feel free to ask your questions and interact. We will discuss all the solutions in detail. Okay. So I'm stopping the share and I will go to my notepad and we will discuss the solutions. So let's get started with discussing the solutions. I want this session to be interactive. I want all of you to ask all the questions, and please, we'll make it more what to say interactive and live session so that all your questions are answered. Okay. So let's get started with the first question. So here I share my screen. So each question given is a very, very interesting and important question covering some very interesting concepts. So x of t is equal to, let me note down the question. It is 3 cos 2000 pi t plus 5 sin 6000 pi t plus 10 cos 12,000 pi t. So, and they are told sampled at 5 kilohertz. So you are sampling the x of n, x of t, and after that you are reconstructing the x or y of t based on the samples. That's what is given. So before even going to the question, solving the question, let us look at it. We know what is the cos omega naught t is represented as cos 2 pi f naught t, correct? So what is the frequency here? The frequency here is 2 pi f, correct? So this is, so divide this by 2 pi, so I will get 1000 hertz. Here I divide this by 2 pi, I will get f equal to 3000 hertz. Here if I divide this by 2 pi, I will get f is equal to 6000 hertz. So f max of the signal is 12,000 hertz, sorry, 6000 hertz. And we know by sampling theorem that f sample should be greater than or equal to 2 f max. So f sample should be greater than or equal to 12,000 hertz to avoid aliasing here. So the first thing we are noting is here f sample is 5000 hertz, 5 kilohertz, which is 5000 hertz, implies aliasing will occur. So let's see. So how x of n will look like? X of n. So x of t is given. So x of t to x of n, how will you get? Replace t by n by fs, where fs is the sampling frequency. So x of n will become, so x of n will become 3 cos 2000 pi. T I have to replace by n by fs, which is 5000, plus 5 sine 6000 pi n by 5000, plus 10 cos 12,000 pi n by 5000. And we know the sampled frequency will be in the order of minus pi less than or equal to your sampled frequency omega less than or equal to plus pi, correct? So this value sampled frequency cannot be more than pi. So let's see. If I simplify this, what will I get? X of n will be 3 cos 2 pi n by 5. So this is less than pi. 2 pi, 2 by 5 pi is less than 1. So it can go up to minus pi to pi, so no problem. 5 sine. Here I will have 6 pi n by 5. So this is greater than pi. So here aliasing will occur. So, and then this will be 10 cos 12 pi n by 5. So clearly this is greater than pi. This is greater. So the coefficient should not be greater than 1. Kindly note this. So 2 pi by 5. So this is perfectly fine because this is less than 1. So this is perfectly fine. So what will happen? This will get aliased. How this will get aliased? So 6 pi n by 5 can be written as 2 pi n. How can I write 6 pi n minus? It should be something. And similarly 12 pi n can be written as 2 pi n plus 2 pi plus 2 by 5. Correct? So this will be, think about this. It will be 2 pi plus 2 pi by 5. Correct? So this will be 10 pi plus 2 pi, 12 pi by 5. That's how it will be. And this I need to get 6 pi by 5. So how can I get 6 pi? 4 pi n by 5. So 2 pi n plus 2. So this is how it will become. So this implies x of n equal to 3 cos 2 pi n by 5 plus 5 sine 2 pi n minus 4 pi n by 5 plus 10 cos 2 pi n plus 2 pi n divided by 5. And cos of 2 pi n plus something, sine 2 pi n plus something will be the same thing. This will be 3 cos 2 pi n by 5 minus, why minus? Because this is going to be sine of 2 pi minus theta is going to be minus sine theta. So minus 5 sine 4 pi n by 5 plus 10 cos 2 pi n by 5. So this is also 2 pi n by 5, 2 pi n by 5. Together it will become 13 cos 2 pi n by 5 minus 5 sine 4 pi n by 5. This is how the signal will look like. Because I am doing a I'm doing an incorrect sampling, I will get this as the x of n. So y of t is formed by reconstructing x of n. So I have to replace n as t into fs. So I will get 13 cos 2 pi by 5 into n as t into fs. So 5000 t minus 5 sine 4 pi n is what I replace as 5000 t divided by 5. So this will become 1000. This will also become 1000. So I will see 13 cos 2000 pi t minus 5 sine 4000 pi t. That's clearly I am not able to reconstruct my original signal. See, ideally what should have happened? I sampled my signal and I reconstruct back. I should get back the original signal. This is the signal I started with, correct? I started with this signal. 3 cos 2000 pi t plus 5 sine 6000 pi t plus 10 cos 12,000 pi t. I should get back the same signal. But because I am doing a undersampling, I am seeing the effect of aliasing. This is due to aliasing. Okay, this is the solution to the first problem. Okay, I hope this is clear. Let's see if there are any questions coming up. Okay, so if there is any question with respect to this session, I will be able to answer. Okay, so next question. This is also another very interesting question. Again, very cunningly given. So second question is given to be x of z equal to z by z minus half into z minus 2. This is the question, correct? Okay. And ROC contains unity circle. So multiple concepts are going to get covered in one shot here. Let's see. What do we know? We know that Z transform of a power n u of n is z by z minus a, and ROC is mod z greater than a. Z transform of minus a power n u of minus n minus 1 is also z by z minus a. Both, kindly note, both of them have the same z transform. A power n u of n and minus a power n u of minus n minus 1. The only difference is ROC here will be mod z less than a. Okay, so now x of z by z is 1 by z minus half into z minus 2. This I am going to split by partial fraction as a by z minus half plus b by z minus 2. So I can find a and b, right? So 1 is equal to a into z minus 2 plus b into z minus half. So at z equal to 2, I will get b equal to 2 by 3. At z equal to 1 by 2, I will see a equal to minus 2 by 3. So what will I get? I will get x of z equal to, I can keep 2 by 3 common outside. B is 2 by 3. So z by z minus 2 plus z minus z by z minus half. This is what I'm getting. So therefore x of n, I can write it as 2 by 3 2 power n u of n minus 1 by 2 power n u of n. Correct? Can I write this? Can I write this? Can I write this? If I say for example, if I'm going to write this, what will happen? Here for this ROC is mod z greater than 2. Here the ROC is mod z greater than half. So when I have two ROC, ROC will be ROC1 intersection ROC2, which means ROC will be mod z greater than 2, which means it does not contain unity circle. But question says x of z has ROC such that unity circle is contained. Is contained in ROC. That means what it should be? It clearly means ROC for 1 by 2 power n should be such that mod z greater than half. The ROC portion for 2 power n should be such that mod z should be less than 2. Then the intersection of these two will be, the ROC will be like this. It's not less than or equal to, it should be less than. ROC cannot contain the poles. That's another important point. So here unity circle is contained. So x of n will look like minus 2 by 3 1 by 2 power n u of n. That is the way it will look like mod z greater than half. Then here it should look like plus 2 by 3. It should look like minus a power n u of minus n minus 1. See, then only the ROC will become less than. Correct? See, here if I write the z transform in this form, inverse z transform in this form, the ROC is greater than. If I have to write a ROC with z less than, it should be in this form. So I should write the 2 power n in this form. So it should be minus 2 power n u of minus n minus 1. This is the correct answer. So all the four options given were very cunningly and confusingly given, but this will be the correct answer. Fine. So let's go to the next question. Yeah, next question is another interesting question. It's about the energy. X of n is 0.9 power mod n sin pi n by 2. Energy of x of n equal to what? This is another very interesting question. Let's solve. So energy of x of n is what? Summation n equal to minus infinity to infinity x of n the whole square. So let's see what happens. So I'm going to write this from minus infinity to infinity to get, see, definitely if there's an infinite series, there is going to be a pattern associated with the infinite series. You identify the pattern, you get the answer. That's how it is. It's very simple. You identify the pattern, you will identify the series. So let's look at this series. So I will have at n equal to 0, I will have 0.9 power 0 sine of 0. So sine 0 is going to be 0 plus 0.9 power 1 sine pi by 2. plus 0.9 square sine 2 pi by 2 plus 0.9 cube sine 3 pi by 2. I'll write one more term plus 0.9 power 4 sine 4 pi by 2 plus so on till infinity. And minus infinity side, what will I get? I have to write the negative terms also, right? So on till minus infinity, we have to write couple of terms here. Let's see. 0.9 power 1 because it's mod n. So minus 1 will also become 1 only. Sine minus pi by 2 plus 0.9 square sine 2 pi n by 2 pi by 2. Correct? Correct? Okay. And of course, there is every term has one whole square because x square is what is being considered. So this is the x. So x squared will be coming. So on. So let's see what is going to come. Clearly, sine pi n by 2 will be 0 for even values of n. Is plus or minus 1 for odd n. Because sine pi, see if I put even number, I'll get sine pi, sine 2 pi, sine 3 pi, sine 4 pi. So sine n pi will be 0. And it will be plus or minus 1, whether it is 90, 270, like that. So odd multiples of 90, it will be correct. So odd multiples of 90, it will be plus or minus 1. So let's see. So how this will look like? Minus infinity to infinity, it is going to go. Zeroth term is going to become 0 because sine 0 is 0. First term is going to be how much? 0.9 sine pi. So this is going to be 1. So 0.9 sine. So sine pi by 2 is going to be 1. So I'm not going to write that. So it's going to be 0.9 square plus 2 pi. Even thing, it goes to 0. Even thing goes to 0. This is 0.9 cube. And sine 3 pi by 2 will be minus 1. But minus 1, the whole square will also become plus 1. So 0.9 cube, the whole square. Plus, like this, it will go on till infinity. Plus 0. Plus, if I see here, this is also 0.9 whole square only because sine of minus pi by 2 is minus sine pi by 2, which is minus 1. But there is a whole square outside, so it will eventually become positive number. So I will have 0.9 square. Again 0 plus 0.9 cube, the whole square. Like this, it will go all the way. So effectively what I will have is 2 times 0.9 plus 0.9, sorry, 0.9 the whole square plus 0.9 the whole square, the whole cube plus 0.9 the whole square, the whole power 5. Like that it will go. I am just interchanging the square and power 3 outside. It will go all the way till infinity. This is nothing but twice 0.81 plus 0.81 the whole cube plus 0.81 the whole power 5 plus so on till infinity. Now this I can write it as, I'm going to write it in a way which is very convenient for me. I'm going to write this as 1 plus 0.81 plus 0.81 the whole square plus 0.81 the whole cube plus 0.81 the whole power 4 plus so on till infinity minus 1 minus 0.81 plus 0.81 the whole square minus 0.81 the whole cube plus 0.81 the whole power 4 plus so on till infinity. Now if you see, all the even powers will get cancelled out, all the odd powers will get added up, and hence it will give me 2 here. Correct. So now what is this? This is 1 plus x square plus x cube plus so on till infinity. This is 1 by 1 minus x if mod x is less than 1, if and only if. And the next series I am having is 1 minus x plus x square minus x cube plus so on till infinity, which is 1 by 1 plus x. This is if mod x is less than 1. So what do I get? So the first series will sum up to 1 by 1 minus 0.81. The second series will sum up to 1 by 1 plus 0.81. So if you simplify this, you will get the energy to be approximately 4.7 joules. So let us go to the next problem. This is the answer for problem number 3. The next problem, that is another very interesting problem. X of z is log of 1 minus 2z. So what is small x of 2? This is what they are asking. This is another very interesting problem. See, if I know the z transform, then I know how to compute the inverse z transform. See, for example, if I have 1 by 1 minus say 2 z by z minus 2 I have, and ROC is given to be, ROC is mod z greater than half. So mod z greater than half means I am going to have a partial sequence. That's what it means. It's going to be in terms of u of n, not in u of minus n minus 1. That's what it says by saying mod z is greater than half. Now see, suppose if I have this, the inverse z transform will give me 2 power n, something like that, correct? But I am having log. I don't know any function whose z transform will give me log for me to take inverse z. So let us look at the properties. Properties of z transform. This is very important. Z transform of n x power n will be z inverse. So if you, okay, let us derive this itself. So what is z transform of x of n? Summation n equal to minus infinity to infinity x of n z power minus n. Now if I differentiate this, what will I get? Dx of z. So this is what is your x of z, correct? So if I differentiate this dx of z by dz, what will I get? All these x of n terms are not differentiated because I am differentiating with respect to x. So n equal to minus infinity to infinity. X of n will remain the same thing. Z power minus n will become minus n z power minus n minus 1. So I am going to bring that minus outside, z inverse outside. I can write it as n equal to minus infinity to infinity. N x of n z power minus n. This is nothing but minus z inverse x of z. So the property is z transform, this is minus z inverse z transform of n x of n. Correct. This is what is dx of z by dz. So this is the property. So I have log of 1 by 1 minus 2z. So I'm going to differentiate. This is my x of z. So implies dx of z by dz is going to be what? So log of 1 minus 2z, right? Log of 1 minus 2z, sorry. I have log of 1 minus 2z. So I will get 1 by 1 minus 2z, which is nothing but if I bring z common outside or 2z common outside, I will have 1 by, what will I get? If I bring 2z common outside, I will have, or rather 2 common outside, I will have z minus half. Correct? This is z minus half. Correct? So therefore, x of z is 1 by 2 into z minus half. So this is dx of z by dz. Correct? Correct? I think this should be 1 by 2 z inverse, I think. No, it's 1 by 2 z. Okay, fine. So using the property, what we can prove? Tell me now how to go about this. Tell me. So now I know the property. What is the property I am aware of? So now let us multiply by z on both sides. So this will be z into this one, correct? So now I have 1 by 2 z by z minus half. So and mod z is greater than half is the ROC. So this will be 1 by 2 into 1 by 2 power n u of n. So this is the x of n, correct? This is n x of n. This is n x of n, correct? So I have to multiply by minus, so there will be a minus also here. So this will be your n x of n. So therefore x of n is minus 1 by 2 power n, sorry, my x of n is 1 by 2n, 1 by 2 power n u of n. Now substitute n equal to 2, which implies x of 2 is equal to 1 by 4 into 1 by 4, which is 1 by 16. So whatever is the answer, simplify this, that will be the answer. Clear? So that will be the answer for x of 2. Now the last question, Fourier transform of u of n, the unit step signal. So the options are very cunningly given. Doesn't exist is given because Fourier transform of x of n exists only when x of n is absolutely summable. Correct? But Fourier transform of u of t, sorry, Fourier transform of u of t. So u of t is not absolutely summable. So doesn't exist may be answer, or many people think that Laplace of u of t is 1 by s. So I replace s by j omega. I will get the Fourier transform. So 1 by j omega like that. But all these are wrong answers. The correct answer is pi delta of omega plus 1 by j omega. This is the correct answer. To prove this, we are going to use the duality property. What is duality? Fourier transform of x of t is capital X of omega. Then Fourier transform of capital X of t will be 2 pi small x of minus omega. This is the clue. So this is the clue I'm going to give you. So based on this, I want you guys to attempt and prove that Fourier transform of u of t is pi delta of omega plus 1 by j omega. Okay, I leave this problem to you as an interesting exercise. Kindly work this and check it out. The property I have given you, this is the, you will be using the duality property here. Okay. Is there any other question, guys? There are no questions. We will close this session. So I hope this session was really informative. Okay. Okay. Wish you all success, guys. Wish you all success. We'll close this session here. Okay. Yeah. Thanks, everyone. Thank you.